This video is over adding functions, so a couple reminders to have when we do this. To add or subtract functions, you combine your like terms, which are the same variables. It could be one variable, two variables, with the same exponents. So x's with x's, x squareds with x squareds. Pay attention to those variables. And then also, exponents do not change when we're adding and subtracting. So the variables, just combine the numbers in front, the coefficients in front, and leave everything else alone. So example 1a, we have f of x plus g of x. Well, f of x is the 2x squared plus 3x plus 2. G of x is the 4x squared minus x, and it wants us to add them. So I'm going to write them out. Plus. Okay, so the good thing with adding is that nothing changes, so we can just drop the parentheses. And now we just combine our like terms. So we have the 2x squared with the 4x squared. That gives me a 6x squared. I have 3x minus x. That gives me a positive 2x. And then I'm left with this constant right here, which is a positive 2. So this right here is equal to f of x plus g of x. This is an equivalent expression. Okay. Looking at letter B, we have f of x minus g of x. So I write f of x first. I'm going to subtract g of x. Now, unlike adding, we can't just drop the parentheses like we did. Although the first set, it gets to stay the same. The part after the minus sign, we have to change. We have to distribute that negative sign to everything after it. So it becomes a negative 4x squared, and then I distributed it to the second term, which is a positive x. From here, now we can just combine our like terms. So 2x squared with a negative 4x squared, that gives me a negative 2x squared. This 3x with a positive x gives me a positive 4x, and this constant 2. So this is an equivalent expression to f of x minus g of x. Looking at part C, it switched the order. We have g of x minus f of x. So this time I write g of x first. I'm going to subtract f of x. Okay, again, the first set of parentheses gets to be left the same. The second set, we have to remember to distribute the negative. So negative times a positive 2x squared is a negative 2x squared. A negative times a 3x is a negative 3x. Fix that mistake. Negative 3x. And a negative times a positive 2 is a negative 2. So now we combine like terms. 4x squared with a negative 2x squared, which is a positive 2x squared. We have a negative x minus a 3x, that's a negative 4x, and then the constant negative 2. So if you look, we do get a different answer, which means subtraction is not commutative, and we need to make sure we keep it in the same order. Commutative means we cannot rearrange it and get the same answer. So there's our answer. Let me box it. Okay, looking at letter D, we notice there's a little change. We have added a 2 instead of an x. So I'm going to start by rewriting it all out. Oops, I was going to write g of x. I meant to write what g of x equals. So we have 4x squared minus x. There we go. Now, anywhere I see an x, I'm going to replace it with the number 2 since it replaced the x in the equation. So I have 2 times 2 squared plus 3 times 2 plus 2. And then over here I have 4 times 2 squared minus 2. Okay, order of operations tell me that I do exponents before I multiply. So I have 2 squared, which is 4 times 2, which is 8. I have 3 times 2, which is 6 plus 2. And then over here, I have 2 squared, which is 4 times 4, which is 16 minus 2. I have 8 plus 16, that's 14 plus 2, which is 16. And then here I have 16 minus 2, which is 14. And 16 plus 14 is 30. So f of 2 plus g of 2 equals 30. Okay, that is one way to do it. Change colors. If I go back up to example A, notice that's when I added f and g. If I were to do that first and then substitute the 2, I would get the same answer. So just to kind of show you what that looks like, if I did 6 and I plugged in 2 for all of my x's, okay, so 2 times 2 plus 2. So again, order of operations, tell me I do 2 squared, which is 4. 4 times 6 is 24. 2 times 2 is 4 plus 2. So 24 plus 4 is 28 plus 2 is 30. So if you wanted to plug it in and then add them, or add the 2 functions, then plug in the 2, you get the same answer. Okay, so moving on to our next examples. We have 2 new functions. We have an f of x that has a fraction and an h of x that has a fraction. So we want to first start off with subtracting them. So I'm going to go ahead and write the function out. 1/2 x cubed minus 5x squared plus 10x minus 3 minus, and then h of x, which is 12 minus 3/4 x minus 2x cubed plus 3x squared. Okay, so we're subtracting. Again, when we're subtracting, the first set of parentheses gets to stay the same. So we get this. Oops, I don't need that. The second set of parentheses, that's where we distribute the negative to everything after it. So I have a negative 12, a positive 3/4 x, a positive 2x cubed, and a negative 3x squared. So from here, I just combine my like terms. So I'm combining the 1/2 x cubed with the 2x cubed. Now, in order to add fractions, I have to have a common denominator. So I want this to have the 2x cubed to have a denominator of 2, which means it becomes 2 on the bottom, on top would be 4. 4 divided by 2 is 2, so that's the same thing. So I'm going to add 1/2 plus 4 halves. That gives me 5 halves x cubed. Then I go to add my x squared terms. My x squared terms is the 5x squared and the negative 3x squared. So a negative 5x squared minus a 3x squared is a negative 8x squared. Then I add my x terms. So I have a 10x and a 3/4 x. So that 10 I need to change to a fraction, so it becomes 40 over 4. 40 over 4, so 40 divided by 4 is 10. So now they have a common denominator. So I have 40 over 4 plus 3 over 4. That turns into a 43 over 4x. And then my 2 constants, I have negative 3 and a negative 12. That turns into a negative 15. So this is f of x minus h of x. Looking at letter B, notice now we have a number in front. This is not replacing the x, so our answers should have x's in them. This is the number that goes in front of the function, and then I have to distribute it before I can do it. So what that looks like is I have 2 times f of x, which is 1/2 x cubed, minus 5x squared, plus 10x minus 3. And then I'm going to add 4 times the function. 12 minus 3/4 x minus 2x cubed plus 3x squared. So I'm going to distribute it first. So 2 times 1/2 is a 1x cubed, or just an x cubed. 2 times a negative 5x squared is a negative 10x squared. 2 times 10x is a positive 20x. And 2 times a negative 3 is a negative 6. Okay, then I have to distribute this 4 to the h function. So 4 times 12, that's a positive 48. We have 4 times a negative 3/4 x, which turns into a negative 3x. 4 times a negative 2 is a negative 8x cubed. And 4 times 3 is a positive 12x squared. Combining my like terms, I have a 1x cubed and a negative 8x cubed that turns into a negative 7x cubed. A negative 10x squared with a positive 12x squared, so positive 2x squared. 20x and a negative 3x. That gives me, what does it give me? A 17x and negative 6 and 48. That is a positive 42. So this is 2 times f of x plus 4 times h of x. Okay. So this is what we get when we do that. This is it for adding and subtracting. So be sure to watch out for other videos.